So I've got you some questions on pseudocode today, and we're looking at strings a little bit. The other thing that we are also looking at is how assemblers work, looking at compilers, that sort of thing. So what we've got here is a piece of code, and you can see this is an array. So names, it's got an array with Lily and Thomas in it. Names 1 is just a string of Sarah. Names 2 is a string of Freddie. Output name 1. What this does, so that you're aware, is it picks the first character from a string. That works out the length of names. So the length of that is 1, 2. Remember, arrays start from 0, but this is the length. So that would be S. In this case, the length of names is 2. And then this here is your starting and finish point of name 1. Okay, and then we're going to output var. All right, so it's now thinking, it's now looking at this, and it's even giving you an example to help you with substrings here. It's giving you programming and says the start point 3, all right, would be there, because we go 0, 1, 2, 3, all right, and we finish at 5, 4, 5. So that is 3 to 5. Yes.
Oh, why is the length of names 2?
The length of names is 2 because we always count array. We always count length from 1. Arrays start at 0. You need to remember those key rules. Len starts counting from 1. Arrays start counting from 0.
No, I was like, because I think I was just counting the characters.
No, length of names. This is names. So what we've got here is an array with 2 names in it. Yeah? So 1, 2. But if it was an array, we would start from 0, 1. So the index would start from 0. Okay? So let's look at the first one. Shade 1 lozenge, which shows the output of line 4. Well, we know that line 4 is S, because 0 is the index of that, which is Sarah. So that should have been S. Okay? Now the next one we hear, it says state 1 lozenge, which shows the output of line 5. Line 5 is the length of names, and there are 2 items in names, so that therefore that is 2. Then it says state the output from line 7. Okay? What line 7 says is start at 0, stop at 3. So Sarah, 0, 1, 2, 3. So therefore you've only got those 4. So you should have output Sarah without the H. Okay, that's how substrings work. You put your start number and your finish number, and those will be the items that are printed out. Alright? Let's go on to D. Alright, it says fill in the gaps. It wants to basically join, alright, it wants to output Thomas Ra. Alright, so what it's doing is it's going to use the 2 parts of that name. Alright, so 2 extra lines are added, fill in the gaps, so the output of the new final line is Thomas Ra. So what we would need to put in there, alright, is if you go to names 1, okay, what we're going to do is join it to the original var, alright, and we want to put in Thomas. So we know, where's Thomas found? Let's go back to that. Thomas, in terms of the array, is found in position 1. So there's the first easy bit. So Thomas was found in names, that's square brackets, 1. Alright, now we know we've got part of Thomas, we need to get Ra, R-A-H. So to get R-A-H, you would look at Sarah, and remember we start at 0, 1, 2, 3, 4. So that's going to be 2 to 4. That's how that works. 2 to 4. And that is how you get that part. Alright? So we've looked at a little bit of string manipulation there, so you can hopefully understand it. Alright? And now we're going to look at how an interpreter works. So here's a kind of breakdown of where your marks come. Now there are two types of mark bands here. One's to show your really good understanding, and one's like you've got a basic grasp of it, all right? But if you've got all of these 4 points, it's going to show that you've got a stronger grasp. So remember, all right, that interpreters, all right, so if you want to make a note of these points, interpreters do not produce any machine code. So the program needs to be translated each time it's ran. Okay? Yes?
Is machine code the same as source code?
No. Machine code is your ones and zeros.
Source code.
Source code is like your original code.
Oh, okay.
Yeah? So then your machine code are your ones and zeros. You need to get it into machine code in order for the computer to actually process and understand it. Yes?
So, is the difference between that and like compiler is that I thought compiler made an executable file and then this didn't. Is that not what it is?
Let me finish this and then I'll explain the difference, okay? So interpreters don't produce any machine code, all right? The program needs to be translated each time it's ran, all right? They call machine code subroutines within their own code to carry out commands. A line, all right, a line is translated one statement at a time, and if a runtime error occurs, the interpreter stops. Okay? So if a runtime error occurs, all right, then a runtime error will, if you will get a runtime error. So a best way to explain this is you all in our lessons have been using things like PyScripter, you've been using things such as Replit, okay? Well, all of those programming languages that you use are using, all right, the interpreter, because what's happening is, think about it, when you get that red error that says, oh, we found a error on this line, do you see what I mean? Okay, but also the other way of seeing it is when you type in an input that it doesn't get, you get an error, because that's it's translating it one line at a time. Do you see what I'm getting at? Because your programming languages run sequentially, what happens is at some point with your interpreter, if there is a runtime error, it halts the program. So a line is translated one statement at a time, and then it stops, the interpreter stops if there's that runtime error. That's what you all experience, and then you have to go back and fix it and run it again. Yes?
Is a runtime error like the same thing as a syntax error?
Syntax errors generally happen before it actually starts running it. It checks it all at the beginning, because syntax errors are the rules of the code. Yeah, runtime error is different. Runtime error, the code has compiled, but you've got an error while you're, yeah. All right. So let's move on to this question. State one lozenge that shows the length of the context in the variable level. Well, if you look here, all right, the len, remember I said we start len from 1, all right? Don't get it twisted. There's 1, 2, 3, but then up here was 4. There are 4 in GCSE. 1, 2, 3, 4. Len starts. So you should have had 4 there. Shade one lozenge that shows the result of concatenating the variable title with level. Well, pay close attention to this because there is no space at the end of that. And there's no space before it. So when you join that with that, all right, what you end up having is computer science GCSE because there was no space between those. So you should have had D there. All right? So make sure you are marking this. Shade one lozenge to show the following strings, which is a substring of title, all right, in pseudocode, all right? So state one lozenge to show which of the following strings is a substring of the variable title. Well, all you need to do is look at this. Here's title, all right, and have a look at how this works. Well, there's only one that it could possibly be because computer has a space before S, so it's not that. Comp sci, you've got all this stuff in the middle, so it's not that. Ter science, again, the space isn't there, so it's not that. So process elimination, you should have just had sci. It's basically asking you what could possibly be right out of this. If you have a look at the string there, there's no space. It's just about you problem solving and just paying close attention to what's going on. Then here, Unicode title 0, which is C in 90, which is C and is 99. State the one Unicode character that level 3 in pseudocode could be. All right. Well, the answer is if C is 99, look at what level 3 is. All right, letter 3. All right, so that's E, 0, 1, 2, 3. Okay, so that's letter E. If C is 99, D is 100, E is therefore 101. Am I making sense? That was a process of elimination there. Just work out that C is 99, go to level 3, which is position 3 of the index of that, yeah? 0, 1, 2, 3, which is the E, and there we go, there you have it, so you should have had 101 there. Alright, now, this is where these get a little bit more complicated. So it's asking you what. We haven't got many of these left, all right? We're nearly done, just keeping an eye on time. For each of the situations below, state whether an assembler, a compiler, or an interpreter would be most appropriate. Now, I was asked at the beginning of this if you could reuse some twice. You can. It doesn't mean that it's right to, though, all right? That's why I didn't want to give you that answer while you were doing the question. So what we've got here is a company has developed a program and wishes to sell to users who will run the program on their personal computers, all right? There's the key point. They're going to sell it. Therefore, it will need to be in its finished form, all right? And the only way you can do that, we run our programs in interpreters while we're in lessons, like the Python interpreter that you use, yeah? But if you want that to be able to just run on the machine, that's why you need the compiler. Within our interpreters, there is the option to use a compiler and turn it into the executable format. All right? You don't want your customers to see that code. That's why we use a compiler. So in that case, you should have used a compiler. And the reason for it is you do not want your customers to see the final code. That's how copyright occurs. Yes?
you say to prevent it from being reverse engineered?
That's yes, but I would extend that a little bit to say the reason why. Why do you not want it to be reverse engineered? So a compiler will not need to distribute the code, all right, and simpler to run. You don't want your customers to have to open up an interpreter every time they run your software. Think about it logistically here. Yes?
Would it not be like, I put interpreter because if you had a compiler,
So I'm going to ask you this question here. Whenever you open up Microsoft Word, do you run it in an interpreter? Why would you? Why do you think that is?
It's for convenience, but I thought that.
No, but you are talking here. You've developed a program to sell to users.
I thought that if you have a compiler, then you can turn into machine codes. Then you're kind of like you can steal it from the business and sell it.
It's very difficult to reverse engineer programs once they've been compiled. It is doable, but it's very difficult to do it. Yes.
Could you also say for justification doesn't require the compiler to be downloaded to the computer? Because compilers need
Yes, that is so. That is another point on the mark scheme. Customers will not want to have their own translation software. Okay. Customers don't want to be installing loads of extra pieces of software to get, it's like if you made a whole program in Python, your customers don't want to be having to install that just so they can run your software. You're never going to make any sales. Yes?
I said that, hackers can easily copy the source code and make their own fake versions of.
Well, you need to actually talk about your understanding that you don't want the source code. Unless you've mentioned that point, talking about customers not needing to see that source code, that's not a valid point. You've got to acknowledge that you understand that with a compiler, you're not going to be distributing any code, okay?
Yeah, but I mean, like, if they get the code, then the fake customers, customers may pretend, like, hackers may pretend to be customers and obtain the source code, and then they can make their own replica.
Yeah, that's fine. Right, the next one says, a school student has developed an app which they want their classmates to use. Their classmates need to be able to use the app on a range of different mobile devices. That is your key point there, because whether or not you know this, when you compile a program, that program can only be run on the same machine model. Okay? So, for example, if you made a program in Python on one of these PCs in the classroom right now, and you compiled it, so you used that interpreter and used the compile module and made it into an executable, if you tried to run that file on a AMD processor, say we've got computers in this class and they're all Intel, but you tried to run it on an AMD computer, it would not run unless it has the same instruction sets on the processor. So this is why, in this case, you would use an interpreter, because interpreters work for the machine model. So in this case, I would have used an interpreter, right? And my justification on it is that the program will need to run on any type of processor. Okay, it needs to be able to run on all different types of machines. That's the key thing there. They wouldn't put that into the exam saying there's multiple devices otherwise. Yes?
But then for the first one, if they have to use in their own personal computer, surely the processors might be different, so you can't use a compiler for the first one either.
The questions, no, the key point in the first one was about the selling of it.
Yeah, but
It says they've developed a program they don't want to sell.
But they also use on personal computers, so surely they'll have different processors. The compiler won't work.
Wishes to who will run the program on their personal computers.
Yeah.
But it hasn't said different devices there. This one has. So those personal computers, unless it's stated that it's different, you've got to assume that they're the same. Whereas in this one, they said different. Okay, that's the difference there. All right, it's a valid point. I get where you come from with it, but it's the key words you've got to look for and take out. Whenever it says there's differences or there's a change, a variation in the question, look for those and underline them, okay? And then it says here, all right, a company is developing a program to manage the engine in a car, has been written. The code to do this is an assembly language as an embedded system and will be installed on very little memory. Well, the key thing here is it said assembly code, all right? So therefore, it's going to be using assembler, all right? And the reason why only assemblers can convert assembly code into machine code. All right. Now let's go through some of the differences. Tell you what, I'm going to do question 6 first. All right, which says state the following types of program translator. What you should have had was A, C, and B. Convert low-level language designed to be human readable into machine code. Low-level language. Low-level is assembly. So that's why. So assembly code is low-level. C, high-level program, line by line, and calls corresponding subroutines. There's your thing there, line by line. And you know, in Python, for example, you write in subroutines. So that is why C. This one takes the entire program and makes it into a single program, which is why that was a compiler. Now the difference is here between a compiler and an interpreter. Hopefully this recording doesn't run. All right, compilers make, I tell you what, rather than me writing this out, I will show you the mark scheme for this one, because there's a lot of points there which I can go through and read with you. All right, a compiler produces object and machine code, while an interpreter does not produce any object code. So the compiler makes that object that can run on that machine. So you can take that finished program and put that object somewhere else on the same machine, I'll say, the same machine architecture. Interpreted code runs slower because you've got to go line by line. Whereas when you compiled the program, it runs instantaneously. Yeah? So like in Python, you would have to run it line by line, whereas in an interpreter, in a compiler, it runs instantaneously. You always need an interpreter to interpret source code, but you don't need to when it's compiled. Think about it. You don't need Python. You don't need, PyScripter to run Word. It's finished. Whereas anything in PyScripter, you have to run the source code. Once compiled source code is that's the thing. Once compiled, once you've compiled it, you no longer need that source code. It will run that object. Interpreter always needs to run the source code when you load it up. So when you go into PyScripter, you always need that source code there. Compiled code can only be executed on the machine with the same processor type. That's what I was saying. All right. Think about it. That's why programs that's why there's a Mac version of Microsoft Word and a PC version, different system architectures. Interpreted code is more portable. You can run it on the cloud. You can run it wherever you want, as long as it's using that programming language. Compiler translates the whole source code at once, and an interpreter analyzes it line by line. Okay? Yes, some questions. Yes.
Can you say interpreter software is required for interpreter and a compiler?
Say that again. Interpreted.
Interpreter software is needed for an interpreter, but for compiler, no software is needed.
That's very vague. Interpreted software is for interpreted software.
Like interpreters, the user needs to download the interpreter.
You need I see what you mean.
Compiler,
I would say that's not really Oh, you could say for a compiler. No, you'd still need a piece of software to compile it. Yeah, I wouldn't use that as a valid point. Yep.
Can you not say that the interpreter will sort of encounters an error that the compiler won't?
Well, it's already compiled, so I wouldn't use that as a point, really. Yeah, because the compiler. Yeah, I wouldn't use that as a point. Yeah, I see where you're getting at with it, but it's not something that I would really go down the path of. Yes.
There's like a compiler only translate it, and then an interpreter translate it immediately.
Interpreter does it line by line, whereas a compiler does the whole thing. So it would just make it into an object that can run on any machine with the same processor.
But then the interpreter immediately executes it, but a compiler doesn't execute. Does that count?
No, because once you compile, I see what you're getting at. No, compiler is more, it creates the object of it, then you run that. Yeah.
Yeah, but then does that count as difference?
I wouldn't really use that. All right. If you were asked to, if you had, say, an essay style question, you can use that as a point to back up what you're saying. Okay. I am going to stop that recording and upload it for you.